Welcome to The Bridge by Bangladesh Angels. In this series, we highlight stories of Bangladeshi diaspora entrepreneurship around the world, bringing lessons and perspectives from such entrepreneurs back to Bangladesh and vice versa. In this episode, we have Munawar Hafiz, founder of OpenRefactory, as speaker, and Nirjor Rahman, CEO of Bangladesh Angels, as moderator.
Thank you guys so much for joining. My name is Nirjor. I'm the CEO of Bangladesh Angels. I will go ahead and introduce Munawar Hafiz. Has been working on program analysis and program transformation technologies to detect security, reliability, and compliance bugs in software for over 15 years. All along, he has been driven by this challenge. Why do bug detection tools stop at detection? What if there were services that not only detect bugs, but also fix code automatically? Over the years, his team at the academic, industry, and startup levels have brought in many firsts. First, correct and complex code rewriting tools for C, first refactoring engine for Go, first bug detection tool for JavaScript and Android, and the first big fixing tool for C, Java, and Python languages. Munawar bhai, welcome. Let's hear a little bit more about OpenRefactory, and then we'll go from there.
Sure. So hi, I'm Munawar Hafiz, founder and CEO of OpenRefactory. And at OpenRefactory, we are fixing the hard problem of, hard but simple problem. We want to help you make a world of software that your clients can trust. But trust is a very difficult thing to achieve. And one of the difficult problems that help or that prevent this trust from being built up is the fact that software has a lot of bugs. And because we are always under release pressure, we want to operate at premium release velocity. The thing that we almost always negotiate with or mitigate with is like we deliver software, but then the software does not necessarily meet the quality requirements that we initially intended it to have. Part of that is because we are human beings, we make mistakes when we write code, and we don't necessarily clear our mistakes before we release the software. So there are different bug detection tools that are out there that has been doing this kind of stuff for a long time. As Nirjor mentioned, I've been working in this bug detection area for over 15 years now, starting from my PhD at University of Illinois at Urbana-Champaign. And just to give you a little bit more background about myself, I have been working on this. My PhD work was considered as one of the early pioneering works in automated bug fixing. So I was asking or posing that challenge, as in why stop at detection? Why can't we automatically fix bugs as well? So the first automatic bug detection or bug fixing tool for a general purpose language, which was C at that point, was built in the academia by one of my students when I was an assistant professor at Auburn University in 2012. And that particular research work won the best computer science research in all disciplines of computer science in that particular year. And it was awarded by ACM at the annual Turing Award ceremony for that year. So I've also received like over $1.5 million in awards from the National Science Foundation, Department of Energy, Google, and Microsoft at different points in my academic career to advance this particular thing. Nirjor was also mentioning that our team at Auburn University, we developed the first refactoring engine for Go language, and it was funded by Google, and we delivered the software in Google, and it is still used inside Google as we know it, albeit an updated version of that. We are not maintaining that anymore. But the point is we have built a reputation, or my reputation has been around building this program rewriting technology, or basically modify a program, do a surgery on the program so that we can also fix security, reliability, and compliance problems in software. That's the context of OpenRefactory and our motto, we fix code automatically. So why do we need automatic fixing? Because the traditional way we are detecting bugs or mitigating with bugs, it's just not enough. And software developers, we are human beings. Even the best of us make mistakes when we write code. And the rate at which bugs are created, it outpaces the rate at which bugs can be fixed. On average, for every 1,000 lines of code that we write, we unintendedly introduce about 70 bugs. And even after all the efforts that goes on, 15 bugs end up in every 1,000 lines of released code. And I repeat, released code. So when these kind of bugs are exploited by attackers, then all sorts of big problems occur. And as such, we see that over 100 security vulnerabilities are reported every week in the National Vulnerability Database that is maintained by the US government. And these are all exploitable bugs, and each of them have a lot of cost associated with that, in terms of mitigation. So just to give you a perspective, the Heartbleed bug, which was detected in OpenSSL software in 2014, but the original bug was introduced in the code, and it was there in the code since 2012. So for 2 years, all sorts of tools went into, were probably used in trying to find that particular bug. Nobody found it. It was there until somebody or some hackers attempted or found it and attempted to exploit it. And at that point, mitigating that cost the whole world $1 billion. So that's the consequences that we want to live with, that we don't want to live in. And if one such event happens, trust in your program erodes. You become like highlighted in Wall Street journals, New York Times, CNN, everywhere. As a CEO, as a business leader in your company, you don't want yourself to be there. So what OpenRefactory does is it allows you to operate at that high release velocity that everybody wants to achieve, but do that, but like cover your back and allow you to still be operated at that premium velocity. So I want to point on, I want to keep this conversation non-technical as much as possible, but just to give you some data point to give you the capability of that. So right now, OpenRefactory has support for developers in 3 languages, Java, Python, and C. This particular comparison data that I will show is done on our Java ICR for Java, or Intelligent Code Repair for Java. Intelligent Code Repair, or ICR, is our flagship product. And so what we did was we did a bake-off study. We did a side-by-side study with one of the leading leading competitors out there that is in the bug detection space. Note that we are the first and only tool that can automatically fix bugs. Everybody else just detects bugs for you. But I want to highlight another problem in the existing bug detection tools that make the overall fight against bug detection a hard problem. So we used a benchmark that was created by the National Institute of Standards, Department of Homeland Security, and Department of Defense of the United States. It is the gold standard in the bug detection industry. It's called the Summit benchmark. And what this does is it has thousands of small programs, each of them relatively small, like about, let's say, 500 to 1,000 lines, not large, but they show you nuances of different kinds of ways a program can be attacked. And how this is used is you run an analysis tool, or you run a bug detection tool on this, and you try to find out how many actual bugs you are able to detect. That is, what is the true positive rate, and how many bugs do you miss? That is the false negative rate of your tool. At the same time, the programs also demonstrate that there are some good problems that your tool may erroneously report as or good parts of code that your program can erroneously detect as bugs. So it is actually not a problem, but your analysis engine or your detection engine can detect that here is a bug, and that creates a lot of noise. And that noise is another major problem. So when you have a noise, that contributes to the false positive of that. So what we wanted to show is we picked up a market leader in this, one of the market leaders in this space. It's called Sonar Source. It's created by, it's called Sonar Cube. It's created by a company called Sonar Source. And what we did was we picked about 1.8 million lines of code from the Summit benchmark, about 10,000 programs that harbored various kinds of the most important Java bugs, namely various kinds of injection attacks like command injection, cross-site scripting, SQL injection, etc. We also looked into other problems that crash programs like divide by zero, and also null pointer dereference, which is the most prominent problem that Java developers face. I'm sure if you have worked in Java, you are familiar with null pointer dereference. And so here's the data. What we identified is across the board, SonarCube identified fewer bugs than ICR detected. So ICR had high true positive rate than SonarCube across the board for all of these bug categories, important bug categories, which means that if you are running SonarCube versus it would have missed some bugs that are out there, and OpenRefactory's ICR solution would not miss those. You will be able to find those. The other aspect is that there's also intelligent. So the SonarCube, it also identified with fewer, with very high false positives. So it produced a lot of noise. So out of those 9,000 programs, or 1.8 million lines of code, it generated 140,000 warnings that are false positive. So again, imagine yourself running SonarCube on your software. It will give you a lot of noise or false warning. So a lot of work that you have to do as a developer or an IT manager or a quality guy in your team is that first you have to weed out which problem to fix in the first place. So that wastes a lot of time. And typical bug detection tools actually operate with 70 to 90% false positive rate, which means that every 10 bugs that it identifies, probably 9 of them are not a bug. So imagine that you get like 1,000 reports, and you know on the back of your mind that 900 of them are not necessarily a right bug. So your majority of your time you're just wasting, and there's a lot in the DevOps cycle that is happening because of that. And you are just basically covering the back of the tool. The tool was supposed to help you, but what you're doing is you're spending most of your time covering the mistake that the tool was made in the first place. And that's kind of the state of the art. So what ICR does, and that's what we project as the future, is we operate with very high precision. And we also introduce bug fixes. So even after all of this effort that you put in triaging and identifying the bugs to fix in the first place, then you have to do all of those things manually. With ICR, ICR will be able to synthesize automatic fixes that you can then readily apply to your source code, and those problems will be gone. So in the case of the Summit benchmark, we were able to generate fixes in 70% of the cases. So that means that out of let's say like 5,000 bugs we identified, about like 4,500 or something like that, for all of those, there will be a fix that is readily available that you can just like verify. You just click and integrate with your system, and then you run your unit tests and etc., and your problem is fixed. How good is that? So that's what we're bringing in. We're introducing this concept of fixers, which and imagine that ICR or intelligent code repair, think of that as it's like a band of Marvel or DC superheroes, and each of the fixers is a specific superhero. Each one has a specific capability. Somebody or one of these will address the null pointers. Another one is going to address the SQL injection fixer, etc. And together they're going to bring in the overall value and get your back and allow you to operate with very high precision and operate at premium release velocity. So what we do is we allow teams to operate with high precision. So when we ran with on that summit benchmark that we mentioned, OpenRefactory's ICR that had less than 3% false positive. Imagine 70% in our competitors, 3% in our cases. So that gives you supercharged productivity, and because of the precision that we brings in. Your developers also become happy because they always want to build features. They do not want to like do the mundane task and fix bugs. So it improves the productivity, it improves the quality of the overall software, and overall your delivery, and your end result would be your customers would be happy, and they will be receiving a trustworthy product. So let's just quickly focus on the market aspect of this. Since we are a startup, we always want to cover like which market is this relevant. So this is a worldwide market of and because there's no market for bug fixing, we are looking into the tangential market of bug detection. And the bug detection is the SAM of that total marketplace right now is about $1.6 billion per year. And what happens is that this is only 13% or about 1/6 of the bigger picture of what this market can achieve. That's because the market currently only focuses on the large enterprise players, and it ignores the small and medium enterprises. And what we want to achieve with OpenRefactory is we want to lower the entry barrier, and we want to allow the small and medium enterprises to be also able to access these kind of technologies. And this offers an exciting opportunity for experimental growth for a premium service that we are also bringing in, which other bug detection tools are not able to provide at this point. So as such, our service is available as the regular private deployment that we do for license-based sales. But at the same time, we have packaged our software so that it is available from the cloud as well. So you can now go to AWS Marketplace or Azure Marketplace. You search for OpenRefactory, you will be able to instantiate a machine right now and be able to use that. And in those cloud marketplaces, we charge for $25 or $25 for every cloud machine hour. And it's actually $25 plus something, which is what the machine cost for Amazon. So it boils down to about $25.40 or something like that. But that's not the important thing. So what the product does is it has three components. There's the analysis engine where all the Deeptech happens. And basically, it allows you to detect these bugs with high precision, and also has the fixing capability and so on. The results are navigated by a reviewer, which allows you to see the results, apply the results, integrate the results to your software development process. And the navigator is the product that basically like ties in this analysis engine and reviewer and creates the overall experience. For both the cloud and the private deployment, or use ICR if you want to deploy it on premises, you will be able to access the engine through your web browser. So you just access the engine through your web browser, you open the navigator, and from then you just point it to where your source code is. You run the analysis, you see the results, you integrate it back to your source code. It's as simple as that. So we have started, so we had the C product for a while. In this for this year, we have introduced the Java product earlier in this year, and since then one of our primary focus has been on the Java product. And the Java product is available on the Azure and the AWS marketplace, as I mentioned. The C product is not available in the cloud marketplace because we it's the complex, because of the complexity of the C build system and also the C programming language. What the problem that we solved in Java, that is make it automatic configurable so that you can deploy it in a low touch model, that problem cannot be solved by C. And it's not solved by, it's not that it is not solved by us. It is a very hard problem that is yet to be solved by the computer science community in particular. So that's why the Java product is available. We have recently released a Python beta product that's in September 2021. And we are also working with some early partners on that, on trial of that. The Python product we want to release, we plan to release it in January next year. And that particular fixer will, and then at that particular point, we are also bringing in exciting new technologies in both our Java and Python fixers that other similar tools do not have. So for example, one thing that we are bringing in these like intelligent code repair, in our intelligent code repair products, is we allow our tool to understand the framework on which your software is built. So these days, we don't necessarily write software or everything from scratch. We use libraries, we use glue code, we use microservices to call other services, and so on. And in this new future that we are living in, or new reality that we are living in, it is imperative that we are always using at a minimum of 10 to 15 frameworks in any software that we're building. And as such, your bug detection tool would need to understand these frameworks or understand the work that goes on behind these frameworks before it can make a judicious decision. In the absence of such, your tools will perform poorly. And you can ask, like, how poorly can it operate if it already has 90% false positive rate? Well, it can be worse. So, and what we are bringing in is even higher precision, because our Java product and our Python product, we can teach these products to understand the underlying framework that you are operating with, and that improves the precision further. One other thing that we're bringing in is we're bringing in AI and ML heavily into this. And by doing that, we are now able to not only detect the cookie cutter bug detection that everybody else was doing. So we were detecting and providing fixes for SQL injection or null dereference or cross-site scripting, etc. But these are problems that everyone solves. And what these do fundamentally is that you have a path in the code, or you have some way in the code, and you deviate in certain way, and the tools try to identify the deviation as precisely as possible, and that's how it detects the bugs. But then there could be problems of logic in your code, as in you intended to write your code in a different way, but for some inadvertent mistakes or lack of understanding or whatever, your logic is bad. And so far, your tools are not able, the tools are not there to be able to understand the logic of your code and be able to suggest you changes in place of that. We are bringing in deep learning, AI and ML big time we have already integrated that in Python. And it is supposed to be released in the alpha release that is slated for November, but then we will also be integrating those features in the Java product as well, where we will be now venturing into logical bugs and identifying that. And how
one thing just want to call out here, you have a very unique structure because you're a US registered US entity, but you've got your development base in Bangladesh. You were serving clients all over the world, including in the EU. And so just want to talk a little bit about that, the fact that, there's something like this is actually being built in Dhaka. We would love to learn more about how did you set up the operations there? How did you recruit talent there?
This is a great question. And so we actually have two entities. There's OpenRefactory, which is a Delaware C Corp. There's also OpenRefactory Bangladesh, which is registered in Bangladesh in order for us to operate there. So we started building a team in Bangladesh about 2 years ago. 2 years, a little bit more than that. And the intent of that was, before that, I mean, obviously the cost was the initial factor. That we had a development team here in the US, but and it was pretty small. We wanted to scale, we wanted to have more people in it, but at that point we didn't have enough money to actually build maintain a development team that is large enough to operate here. So we took the risk, which seemed risky at that particular point, to get into Bangladesh and build a development team. My background is from BUET, so I know about the capability of that. What I had capability of the BUET students and what they can do. The problem that we had was, how did we manage the team, or how would we manage the team, and where would we get the talent? How would we retain the talent? So I also worked in BUET for a while before I moved into the US. So I had my colleagues who are now like associate professors, even department heads in BUET at this particular point. So I connected with a few of them and actually asked them to help us in this process to get us good people or recruit good people, and also like get operate with them, and they will have a better understanding of the ground of like what are the intents of those developers, and do they want to stay with OpenRefactory for a long time. So retaining the people, so training the people and retaining the people, like after we do all the hard work in training, retaining them is a major challenge. So having this connection with BUET helped us big time. We have worked with people who are not from BUET for some time. We have had several times internships offered, and there were people from other universities who have interned in our place. And right now we have a team of 8 developers, and we in Bangladesh. All of them are operating from home because of COVID, which kind of worked for us because we were like operating from Bangladesh and US in the first place. So we were all familiar with this long distance operation in the first place. So the initial challenges were, how do we get the talents, how do we retain the talents, and how do we keep them motivated? The guys are very capable, no doubt about this, and that was the most satisfying factor. And now we have a team that we can boast that can go toe to toe with any software bug detection teams that I have worked with I've worked at the leading bug detection company, and I can compare my team with those guys and the capability or the thought process that we have developed in those teams. So it needed some work, but now that we are there, it is extremely satisfying, and turns out to be a very judicious decision that we opted that way and had an operation back in Bangladesh.
A question that came in with that perspective, right? So for those who might not be familiar, but most of us are, BUET is the Bangladesh University of Engineering and Technology. It's the highest and most well-known engineering school in the country, and produces thousands of world-class talent who are working everywhere. Some of you are from BUET. So what is your expected retention of BUET grads in the number of years on average? Do you think it's practical to assume CS grads from BUET can be retained for more than 2 years? Because that is a challenge, right? They want to go abroad, they want to go do PhD programs, etc.
Yeah, when we do recruiting, we do ask people about whether they would want to stay us for a period longer than that. We have seen that kind of stuff, as in we have 2 of our guys who have now moved to US and have started studying here. So yeah, I mean that's going to be a problem that we have, but we have other blend. Like there are other people who have been with us for some time, and they plan to stay with us for some time. So when we do the recruiting, we do ask that question, but then people, and because there are like BUET professors involved in that, people tend to be more practical in their answers, or more pragmatic, or pragmatic with their answers, or that kind of matches what their expectations is when they're providing answers at that first in the first place. And So yeah, I mean, there's a few people who have moved, two, but then we have hired people in place, and we plan to go into a churn. And this is similar for other software companies as well. Like even for the big software companies, people get poached, move from one. So knowledge does not get stagnant with some people. There's always like backup in knowledges that we create. And so we have so far been operated pretty well and never felt the void of like suddenly somebody leaving and then we can't do something else. That has never, at least so far, has not happened with us.
Awesome. And Razim Bhai, please let us know if you have any follow-ups to that as well. I do want to call out, the EU connection a little bit more closer, right? And I think there's two elements here. So one is you've taken investment from Aisi, and so we'd love to learn more about how they came about, what did they see in the particular kind of team and the company and the value addition they're bringing to the table. And second, you are penetrating to the EU market, you do have plans for it. And just curious, how does that work compared to, say, trying to sell to the US market or say to the Australian market or other markets that you operate in?
Yeah, so Aisi has been operating for some time, has been very successful in the EU market, as I understand, and also they are heavily focused on deep tech and AI. So we got connected with them back in December, and then we went through a long due diligence process. We had nods about funding, or they will be joining us in around March, but then we had a long due diligence process. Eventually, closed the deal in July, August of this year. And what they're bringing in is they're bringing in the logistics, their foot on the ground, a very strong presence in the Eastern European community, but at the same time, they also have presence in the rest of Europe and have good connection in places in UK, France, and others, and Germany, etc. And specifically, so what they're helping in is bringing us to our initial clients to build the initial credibility. So one of the clients that we're working on, it's a company called Entity. It's based in Czech Republic at this point. They're heavily on Java. They are a services company, as in they provide software development services for other clients. And we are very close to like signing them as one of our customers, and basically they are using the technology. So overall, the product speaks for itself. Our process is very simple. We connect with a customer. We basically show our demo, and at that particular point, we have almost always seen that the customer's eyes light up because they see the difference. I mean, you can demonstrably show that the precision or the lack of it of the existing bug detection solutions that they have and what OpenRefactory solution provides them. And in the case where those clients do not or have not used a bug detection solution, it's always an wow moment because they see that these or that bugs have been identified that were probably there in their code, in relatively mature code in the first place. And suddenly this tool is detecting that. So when we get to the clients, or have POCs or closer to the POCs, the product actually speaks for itself. But what Aisi is helping us doing is creating this name brand, making us go to these trade shows, etc., that we were previously unaware of, and then making our name visible in the European community overall. That's how they're bringing in their help.
Excellent. On the product itself, can you do regular security checks on codes, and how do you guarantee the repairs provided are good codes?
Yes, so our fixes are done conservatively in the sense that we only suggest fixes if we are 100% sure that we can do that surgery with surgical precision. I've done theoretical work back in the academia. You can look into my previous works of how we do it. So I don't want to go into the technical details, but basically one of the key aspects that we are bringing in the fixing technology is to just make that surgery precise enough so that the problem in the software that is gone, but the good path behavior of the code, whatever the software was doing when some malicious attack was not happening in the code, that is retained, and we don't make any changes to the code. And as such, because we want to maintain that precision, we are not suggesting fixes in 100% of the cases. So for example, at this particular point, our fix rate is about between 50-55%. So out of all the bugs that we fix, in about 50 to 55% of the cases, we are able to generate a fix automatically. And those fixes are guaranteed to be high quality, as in they should not break your program. We are working on expanding that percentage number. We plan to get to 70-75% at some point in future, probably in Q1, end of Q1 or early Q2 next year. We want to get to about 70-75% of fixed rate, but there is a theoretical limit behind that. I don't expect our tool to go beyond that, or for that matter, any tools to go beyond that. And to put into perspective, other tools do not have the fixing capabilities, so they have 0% fix rate. We will get to about 70-75% for all the bugs that we detect by Q2 next year.
Thank you all for joining today.